In 3.5, part 3, we are going to talk about the symmetry of a function. Now, if you can plug a negative x into a function, simplify it down, and it goes right back to the original, if it is unchanged by doing that, we say that that graph could be reflected about the y-axis. It is called an even function with y-axis symmetry. And you can see we can fold this across the y-axis, and it doesn't change the picture. Now, an odd function, if we plug negative x into our function and simplify it down, it's as if we multiply the original function by -1. That would have origin symmetry. So if we rotated it about the origin 180 degrees, then it would be back to its original. So I think if the point xy is on the original, the point -x, -y would also be on the original. So if you have a piece in the first quadrant, because of that rotation, you should have a piece in the third quadrant, or vice versa if it was 2 and then 4. So y equals x cubed is a perfect version of something that is an odd function with origin symmetry. Now, it's not completely related to the fact that, we have an even power and an odd power, although that can help guide you with these. But it is all about if you do the algebraic test where you stick in negative x, what happens to the function? If it goes right back to where it started, then it is an even function. If it becomes the exact opposite, it is the odd function. Now, some functions won't have any particular type of symmetry, and if that is the case, you just leave it alone and you just say neither. It doesn't have those types of things. It's not even, it's not odd, it's something, its own unique thing. So let's look at these graphs here to see if they are even, if they are odd, what are they? It says the functions are given below, and for the functions, decide if they are even, odd, or neither from the graph. Well, if this function was even, we could fold it across this line, and we would not change that function. But if you can see, it doesn't have, this piece would have to go like that. There'd have to be a piece over here. So it's definitely not even. So let's cross that out. For it to be odd, we should put a push pin here in the center. And if we rotate it 180 degrees, we would get the same thing we started with. So there should be a piece down here and kind of a piece going like that. And so no, it's almost, it's close, but it seems like it's not quite centered right on the origin. So it has to be kind of centered around the origin. So it is not odd, it is neither. Let's look at function s, the one we see right here. It is definitely not even. We can't fold it across the y-axis, or this piece would have a mirror piece right there. So it's not even. If we put a push pin in the middle and we rotate it 180 degrees, we do get what we started with. It is odd. This point here is kind of a mirror image. I always think of a kind of a flip-flop. I got to flip here and then flip here. So you have to flip twice, 90 degrees here, 90 degrees here, until we flip across the origin. So that is an odd function. Now, it's nice to be able to show this from the graph, but I want you to be able to show this algebraically. So that's where these two come into play. So we're going to test it. We are going to test it by plugging in negative x. If when we plug in negative x, it goes right back to its original thing. That tells me it's even. If I plug in negative x and it becomes the opposite of what we started with, that tells me it is odd. And if some pieces change and some pieces don't, it's neither of those things. So let's look at the g of x they've given us. So you're going to take and you're going to plug in negative x. Every place we see an x, you are going to take it out and you're going to input negative x instead. Now, an odd power on a negative keeps it negative. An even power on a negative changes it to a positive. So this first piece becomes a positive x to the fourth. The second piece becomes a negative x cubed, but since there's a negative there, a negative times a negative would make a positive x cubed. And then just take a moment and compare it with the original. Did it go back to the original? Oh, sorry, there's a 2 there. Does it go back to the original form? No, it does not. So it's not even. Is it like we multiplied the entire thing by -1? No. This piece messed that up. So it's not odd. It is neither. Now let's do it one more time. Okay, so we're going to plug in negative x. We're going to see what happens. When we square a negative, it goes right back to where it started. It becomes a positive. So that one, you'll notice, is an exact duplicate of our original. So that one is even. So if you have a graph, does it fold across the y-axis? Even. Does it allow you to put a push pin at the origin and spin it 180 degrees? That would be odd. For algebraically checking it, if you plug in negative x and it goes away, it's even. If you plug in negative x and it's like you multiply the function by -1, then it is odd. Let's take a look at this one. It says decide whether it's an even, an odd function, or neither. Well, for f of x here, if I plug in negative x, put it in parentheses, 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 the negative on that, inside that square goes away. And you'll see it looks exactly like we started again, so it is even. Let's take a look at g of x. So we're going to plug in negative x. We're going to see what happens. So every place I had an x, I plugged in negative x. Now this front one makes it negative x times the absolute value of 4 minus x. Here's the thing. Because this piece changed, it almost looks like it should be an odd function. But this piece here, only part of it has changed. That 4 didn't get something that would change it. And so it's not even, it's not odd. Well, let's scratch this out. It is neither. Parts of it change, parts of it don't. It's neither of those things. Let's look at h of x. Plug in negative x, watch what happens. If you have that negative x in parentheses, when you square it, it becomes a positive again. And it looks exactly like the original. So it is even. Let me show you an example of an odd because we haven't seen one yet. If we have some function let's call it x cubed minus x. If we want to check its symmetry, if you plug in negative x, The first piece has 3 negatives, so that's going to become a negative. The second piece has 2 negatives, that's going to become a positive. It's as if you took both things and multiplied by -1. You multiply the entire equation by -1. That is an example of an odd function. So that is all you need to know about even and odd, and then you should be able to finish up all of your 3-5 homework.